The Earth and the Moon have been the best companions since their formation, with the Moon having a significant impact on Earth's conditions. What do you think would happen if the Moon were to suddenly disappear? Share your thoughts with us. The Moon was formed about 4.51 billion years ago during the formation of the solar system, and this event, the Moon's formation resulting from a type of collision, created a suitable environment for life on Earth. But what would happen if the Moon suddenly vanished? Losing the Moon would not only make our nights much darker but could also lead to catastrophic disruptions in Earth's climate and wildlife. Without the Moon, Earth's atmosphere would be different. Without a suitable atmosphere, the exact amount of gases needed for life wouldn't exist, and without the precise combination of appropriate gases, we wouldn't see life as we know it on Earth. Every planet and its moons exert gravitational pull on each other. This law also applies to the Earth and its only moon, the Moon. As a result of the gravitational pull exerted on Earth by the Moon, we experience tides. Simply put, tides are the rise and fall of the ocean, sea, lake, and essentially all water levels on Earth. In the sea and ocean, tides are particularly significant due to the massive volume of water. Without the Moon, tides would be much weaker, about 50 to 75% lower than today, with only the Sun's gravity playing a role. While tides would still exist without the Moon, they would be significantly weaker, leading to a slower circulation of materials along the world's shores. Animals like crabs, clams, starfish, and snails heavily rely on tides for their survival. Tidal movements play an important role in Earth's climate, as they help guide water currents that, in turn, distribute warm water around the globe. Without tides, regional temperatures could become more extreme, both cold and hot, and unusual weather such as storms would become much more common. The Moon reflects only about 3 to 12% of the sunlight that hits it, but that's enough for objects to be at least somewhat visible at night. Without the Moon, nights would be darker, and many nocturnal animals, like owls and lions, would become severely disoriented and some would quickly go extinct due to their inability to find food. However, some survivors would thrive. For example, rodents that hide when the Moon is nearly full would be content in a moonless world. Over billions of years, the Moon has had a substantial impact on Earth and consequently on life. For example, early in its history, Earth completed a rotation on its axis every 4 hours, but this rotation gradually slowed to 24 hours as the Moon drained energy from Earth's rotational force. Earth rotates around an axis that is tilted about 23.5 degrees, which is why we have seasons, not due to Earth orbiting around the Sun. During summer, the northern hemisphere tilts towards the Sun, making our days longer and the weather warmer. Conversely, in winter, the northern hemisphere tilts away from the Sun, resulting in shorter days and colder weather. The gravitational pull of the Moon stabilizes Earth's rotational axis. If the Moon did not exist, Earth's axial tilt could vary between 10 to 45 degrees, changing constantly, leading to chaotic weather and seasons. If the Moon were to disappear, these events wouldn't happen immediately because Earth has significant momentum, but they would occur gradually, perhaps quickly enough that life wouldn't have time to adapt. Consider that some ice ages began with just a degree or two of axial tilt change. Could we lose the Moon? All hypothetical scenarios described are just thought experiments, but is a future without the Moon really possible? The Moon was formed from the remnants of a collision between the early Earth and an object the size of Mars, and compared to now, it was much closer to Earth at that time. Early on, the Moon may have orbited at a distance of about 22,500 kilometers, whereas today it is around 402,336 kilometers away. If you looked at the night sky billions of years ago, you would have seen a Moon that appeared 20 times larger than what we see today. The reason the Moon is slowly drifting away from Earth, at a rate of about 3.78 centimeters per year, is related to Earth's tides. Due to the rotation of the Earth, tidal bulges move slightly ahead of the Moon in its orbit, transferring a small amount of energy to the Moon and consequently sending it into a higher orbit. As a result of the tidal interactions between the Earth and the Moon, the Earth's rotation slows down, and the Moon's orbit expands, with both effects mutually balancing to conserve angular momentum. Over time, Earth's days become longer, by 1 second every 50,000 years, and the Moon continues to drift away, but this will not continue forever.